I'm dead inside, and so are you. And to explain, I'm going to have to talk about what you and I are, what we're made of, and what it means to even be alive at all in the first place. Now, what life is doesn't actually have a completely agreed upon scientific definition, but let's try to get a handle on it anyway. Something is generally considered to be alive when it has most or all of these characteristics. There are 7 of them, so we'll go through really quick. The first one is homeostasis, which is regulation of the internal environment. Next is organization, being composed of cells. Then we have metabolism, transforming energy, converting chemicals, and decomposing organic matter. Growth, which is growing in size and structure. Adaptation, becoming better able to live in its habitat. Response to stimuli, so doing different things based on the immediate environment. And reproduction. So that's the definition we're going to be working under, something that meets most or all of those requirements. Now let's talk about what we're made of. You are made of organs. This is a simple diagram of many of the organs in your body. Some of them you probably know, like the brain and the lungs. Other ones you might not have heard of, like the thyroid or the nasopharynx. But the real question is, are your organs alive? Let's take a look at the brain, for example. It's definitely made of cells, so it matches organization. It metabolizes, it uses your energy to think for the most part. It definitely grows over time, responds to stimuli, seems like it's alive. And most of your other organs will meet at least a few of those criteria, especially responding to stimuli. And actually a lot of them respond to stimuli from other organs. Our organs fit some of the definition of life. But what are they made of? There are many substructures in all of our organs. But let's just go all the way down to the cellular level. Now, just like your body has smaller components called organs, a cell has smaller components called organelles, which you can see in this diagram. Now, before we talk about the organelles, let's talk about at the cellular level. Cells do maintain homeostasis. By organizational definition, meaning made of cells, I suppose a cell is made of a cell, so tautologically it passes. They metabolize, they respond to stimuli, great. The cell is alive. But let's zoom in at some of these organelles. Take cytoplasm. It's the liquid that many of the organelles in the cell float in, and it's mostly water and salts with a few organic molecules. But the thing about that is water and salt aren't organized, they don't metabolize, they don't adapt. Water and salt aren't alive, so cytoplasm isn't alive. Okay, so what's going on? A large chunk of the inside of the cell we've now established is dead instead of alive. And this happens a ton with organelles. They almost all fail our life checklist. I won't go over all of them individually, but let's take a look at one that definitely does meet our criteria for life, which is the nucleus, specifically the DNA in the nucleus. Now, if you like biology enough that you're even watching this video, you probably know that DNA looks like this for the most part. Although this is a little oversimplified. Can actually look like this. This is A, B, and Z DNA. But we'll stick with the simple version for now. Now the DNA doesn't do homeostasis. It doesn't metabolize. It doesn't respond to stimuli. The only thing that it does do is reproduce itself. The way it does that is by unzipping, going from one strand here to 2 half strands. Then it builds component parts of DNA called nucleotides and filling the gaps. It can do that because there's only 4 things that make up DNA: adenine, thymine, cytosine, and guanine. And DNA is able to reproduce by splitting this way because the pairs are always the same. Adenine always goes with thymine, and cytosine always goes with guanine. So even with only 1/2 of the strand, the DNA is able to reconstruct its other half just by matching. So let's call DNA alive, even though it's starting to fail a lot on our checklist. But if you're good at pattern recognition, you probably know what we're going to do next. We're going to take a look at what those nucleotides are. This is the chemical structure of adenine, guanine, cytosine, and thymine. We'll take a look at cytosine because it's the simplest and easiest to understand. Now, cytosine can't do any of the things that we associate with being alive. It doesn't reproduce, it doesn't adapt, doesn't respond to stimuli, doesn't grow, nothing. It's just these 7 dead atoms. And these dead structures are in every cell of every organ, of every human on Earth. We're filled with the dead. You might be thinking, why am I calling them dead and not simply not alive? Well, think about where you got them from. We eat dead plants and animals. I ate a hamburger and the cow's dead parts and the lettuce's dead parts and the onion's dead parts are now my dead parts. And the real miracle of it is that all of these dead parts working together somehow make something that we consider to be alive, which is us. I think that's pretty cool. Anyway, that's it for this time. Thanks for watching, and thanks to Hyde and Jordan Beagle for supporting by being members on YouTube. If you want to support the channel and keep the videos coming, go to the description. You can support on YouTube or on Patreon. I really appreciate it. Oh, and don't forget to subscribe. I'll see you next time.